So the temperature of the copper, I apologize, is going to be equal to 205 degrees Celsius, and then the temperature of the aluminum is going to be equal to 0 degrees Celsius. We have the surface area of the copper rod is going to be equal to the surface area of the aluminum rod, and this is going to simply be equal to A. And then we can say that the thermal conductivity of copper is going to be 380 joules per second per meter per degree Celsius, and then the thermal conductivity of aluminum will be equal to 200 joules per second per meter per degree Celsius. So we can then say that the heat transfer in copper must be equal to the heat transfer in aluminum. So essentially, this is a conduction problem, and we find that this is going to be the thermal conductivity of copper times A times T of the copper minus T mid. T mid is what we're trying to find. So that's the temperature in the middle. And then we have divided by L, the length of the copper rod. So we can say that we can say that this is going to be equal to the thermal conductivity of aluminum times A times T of T mid minus T aluminum all over L. So again, referencing the surface areas, A is going to cancel out, and we find that the T mid is going to be equal to the thermal conductivity of copper times the temperature of the copper plus the thermal conductivity of aluminum times the temperature of the aluminum divided by the thermal conductivity of copper plus the thermal conductivity of aluminum. We know that this is going to be 0 because the temperature of aluminum is 0 degrees. So that means that that term is going to be 0, and we're finally ending up with 380, 205, 380 times 205, and then we'll have 380 plus 200. And we find that T mid is going to be equal to 134 degrees Celsius. This will be our temperature where the two bars meet. And that's the end of the solution. Thank you for watching.